Hello there, math fans. As I thought about giving you an introduction to vectors, it reminded me of something that comes up a little later in our course where students are asked this question where they have to talk about cross products and determine which way things go. And that's later in the course. But it always comes down to this one spot in the problem where the students are asked if the first component of a vector is positive, negative, or zero. And then it asks, is the second component positive, negative, or zero? And is the third component positive, negative, or zero? And it's a multiple choice problem, which students don't like because they don't get 5 tries. And so they're going to have to do these parts, and they're like sweating and sending me an email, and they're like, I have no idea how to tell if a vector has a positive, negative, or zero component. And what I've found is that means they have a misunderstanding about vectors in general. So let's talk about tilt. What does it mean if this is positive? What does it mean if this is negative? What does it mean if this is zero? Those represent changes. So if you go from head to tail, X is going to go up. Let's think about what that means. And I think this actually gives a pretty good understanding of what a vector is. And in this course, this is the coordinate system we're using. So positive X is towards us. So when I look at this, positive means the vector is towards us. Now it does depend on where we're standing, but coming out of the page, so to speak. Negative means away from us. And zero means neither towards us or away from us. You can think of that in many different ways. You could even draw a little wall. Look at the wall in front of you right now. If I gave you a vector, would you be able to tell if that vector points towards the room away from you on the other side of that wall? For me, that would be outside. Or towards me. I think we can tell that. For example, this purple vector over here, which is this vector, and I've drawn it from the origin, can you see if that vector points towards us or away from us? Ignore everything else, only look at what happened to the X. If you walk from the tail to the head, do you get closer to us or further away? You should see you get closer. You should see X is getting bigger. There's the positive X axis. You go from tail to head, you get bigger. It's towards us. It doesn't matter where, and I've made it so I can move the tail. It doesn't matter if I move the tail back there, but there you can really see it. If you move the tail back, you can see that it passes through the XZ plane. I don't know if this helps. I'll draw this as well. So what about X equals 0? There's the plane. Let's do a different color because that looks funny. That also looks funny. You can see if you put that vector, it's towards us. It's not pointing into the far room. It's pointing towards us. Doesn't matter where I move it to. I can move it down. I can move it out. I can move it over. No matter where I draw this vector, it points in a way that if you go from tail to head, it's towards us. The X is positive. Okay, what can you say about the Y? Well, the Y is negative. What does that mean? It means it's to the left. And so I think this helps you understand just thinking about positive and negative. So if this is positive, it's going to mean right in our coordinate system. If this is negative, it's going to mean left. And incidentally, if it's 0, that means it's going to be parallel to that planar axis. So similar idea. What if I draw this? I look at the wall to my left or my right. What can I say about that vector relative to that wall? No matter how I move it, does it point towards the left or towards the right? It's the left. If you go from tail to head there, you can see it it makes it vanish if I go outside my box, but it goes from tail to head. The Y got smaller. It doesn't matter where I draw it, you can see the Y got smaller. It doesn't matter if I move it here or here, the Y got smaller. That's what negative means. So this vector, when I read it, in my mind, if I want to do a quick little rundown, I would say toward us. That's what positive means. And to the left. That's what negative y means. And then finally, the fact that this is 0 actually means, well, let's think about the last component. What can we say about the last component? If the last component is positive, it means it tilts up. So this would mean up. And this would mean down. Now this vector tilts neither up or down. The z doesn't change. It's parallel to the ground. So the 0 means parallel to the ground is what we would say about this. This is parallel to the ground. So we're so used to slope and finding when the slope is 0 in calculus that we're not used to having to think about them as separate things. But there you go. So now you can quickly go through several more. Let me draw a few more of these. Let's do the next one. -2, 0, 3. What can you tell me about that vector? Let me get rid of our plane. Doesn't matter where you put the tail. What can you tell me about it? Does it tilt toward us or away from us? Away from us, you can see that. And you don't even need to look at it. You can see here that this means away from us. This means it's parallel. The y doesn't change. That means it's parallel to the xz plane and it's tilted up. Doesn't even matter if this is 0.3, it still tilts up, just a lot less. If I change the z to 0.3, I'll show you that in the picture, it still tilts up, just very slightly, but it still tilts up. Okay, what about 4, 3, 0? We would say toward us, that's the x component. We would say to the right and parallel to the ground. So let's look at that. Toward us, so we're going to do 4, we're going to do 3, and we're going to do 0. We're going to put the x-axis towards us. It's towards us, to the right, and parallel to the ground. So I hope this gives you a nice little start for how it works. Doesn't matter where I draw it, it's still from tail to head, towards us, to the right, and parallel to the ground. What about the next one? We would say this is parallel to the YZ plane. Because that means that X is not changing. We would say it's to the left. That's what this is saying. And we would say it's tilted down. That's what that's saying. So if I show you that, let's take a look at that. 0. So I don't know if this will help, but when you get to that homework question, hopefully you'll know that in this case, it's tilted down a little bit. We can see that because of the -1. It's tilted to the left. Let's move it somewhere we can see it better. It's tilted down a little bit. It's tilted to the left for sure. And it's parallel to the YZ plane. 0, 0, 10 is straight up. So if I did 0, 0, 10, it's straight up. So it's tilted up, and it's not tilted to the left or right, and it's not lifted towards us or away from us. Now, going back to the first one is the homework question. So a student who watches this will have the answer to that homework question that's coming later. And the issue and the problem is they don't tell you the numbers. And that's what the students get confused. All they tell you is that this vector is perpendicular to 2 other vectors, and they don't tell you the 2 other vectors. So it requires thinking. So in that homework question, it says, imagine you have this purple vector that happens to be perpendicular to these other 2 vectors. That doesn't quite look right, does it? Let me do a quick look at why my numbers are wrong. Oh, I switched 2 numbers. I'm going to fix it right now. So there you go. You got this purple vector that's perpendicular to the other two. And the question does not tell you any of the numbers. It just gives you that picture. And so for my students, you'll see this eventually again. And it's a multiple choice question. And you are going to have to correctly select plus, minus, or 0. Plus, minus, or 0 for that vector, that purple vector. So you can think about it now. Can you say with confidence, is that purple vector towards us or away from us? Is it to the left or is it to the right? Is it tilted up or is it tilted down? Or neither. So if you should be able to look at that, challenge yourself and click these, and then you won't have to sweat it when you get to that homework question later. All right, hope that helps.